Hail and well met, friends, and welcome to episode 2 of Deep Travel, my space engine series. In this episode, we'll be determining what stars we want to explore at what sort of vessel we'll need to get there. As you can see, we have 3 small spaceports, or 1 small one and 2 big ones if you prefer to think of it that way. The more well-known ones are Cape Canaveral in Florida, and Guiana Space Center at Kourou, although these clearly are more futuristic versions. The other is my own fictional spaceport El Tercero, located on the Oklahoma-Texas border, about 100 miles northwest of Dallas. All craft departing the Cape or Kourou will launch vertically, like a rocket. At El Tercero, small ships such as the Shuttle or the Skylone will launch horizontally as if taking off from a runway, although they may hover first like a Harrier, while anything larger will do a rocket-style takeoff. Here's our itinerary. I have chosen Alioth as our first destination. This choice was inspired by a flight to this system shown in Jack McDevitt's novel, Cauldron, although the space engine version of the system is very different. Some basic facts: Alioth is 81 light-years from Earth. It's a Class A blue star and thus very unlikely to harbor any life, but the game version has some planets that might be worth a closer look. The only starship we have is the Maxwell, an SS Science class. We won't be taking the shuttle with us on this trip, but we will have one on our second trip here, and at that time we'll be landing on Seabright, the 4th planet. I chose this name from McDevitt's novel as well, although again, the Seabright in Space Engine is quite different from the one in the book. After this there are at least 2 other star systems we'll be exploring. There are planets there that I have already named, although I won't officially apply those names until we get there. So let's get underway.
There are a couple of ways we can do this. If I were crossing to the other side of our galaxy or traveling to another one, I would aim for the sun, set a nice safe offset, and slingshot around it, dramatically increasing our speed. I would then fire the engines while close to the sun, taking advantage of the Oberth effect to reduce the time needed to accelerate to nearly the speed of light. This is because the warp drive becomes more efficient and generates a higher effective velocity, if your physical velocity is high when you jump. But we don't need to do that for this trip. At the velocity required to leave our planet and ultimately our solar system, the warp drive still flies us at 1 light-year per second, more than 30 million times the speed of light. That will get us to Alioth in less than a minute and a half. Yes, space engine vessels are that insane. So the first thing we have to do is get well away from the Earth. The autopilot on this thing is not very bright, and will burn in whatever direction is required to align our flight vector with the target star. Never mind if there is a planet in its way. A ship with this velocity and this mass impacting Earth would constitute an extinction-level event. Wait, hold up folks. I thought you said our first stop was Alioth. No. I said our first destination was Alioth. And it is. But our first stop, that's an important distinction, is Lambda Butis. Opening the throttle. Don't worry, it's just a detour. We won't be there long. But why are we going to this random star that doesn't even have a proper name? Because Lambda Butis is near Alioth's ecliptic plane, where the planets we want to visit are. So coming into the system from that direction will save us the trouble of aligning our inclination to those planets. We'll do the same thing when we return to Earth. We'll drop by the Pollux system and then warp out for Earth. Main engine cut off. Notice that our orbital eccentricity is now greater than 1, meaning we are no longer in orbit around Earth. Now we'll wait until we have sufficient clearance, before starting the jump procedure. It will take about 45 minutes to get to a safe distance. See you then. Okay, so I forgot about the 45-minute clearance, and forgot to fast forward the time to now. You're not a far future starship captain, don't judge me. Whoops. Abort. Abort. Sorry about that. These starship controls are a bit tricky. Okay, correcting our alignment after that little fiasco. Engaging Alcubierre drive. This trip was faster than usual due to the high physical velocity from our incorrect alignment burn. See what I mean about that? Now setting up for the next leg, and our destination. Lambda Boötis is the same spectral class as Alioth. Isn't that interesting? There are also planets in this system that we'll be visiting on our return trip to Alioth when we bring the Denali, our shuttle. Alignment complete. Preparing to warp out for Alioth. Those impossibly far away stars just drifting by like that has to be the coolest thing I've ever seen. And that's it. We're here. Is this thing cool or what? Laying in a course for Seabright. Look how close we are to the plane of the system. Our detour strategy worked. The autopilot has chosen a flip and burn maneuver, with 10 hours on each end. But we're only going to do 5 hours. Then we will calculate our stop distance using a simple formula and begin deceleration at that point. Why do it this way? For that matter, why not just warp to the planet and have done with it? The answer: experience. I've found that warping within a solar system is a dangerous maneuver. The warp computer is pretty reliable for bringing us to a safe distance from a star. But a planet not so much. It brings us in so close that we won't have time to construct a proper orbit before doing a multi-gigaton belly flop into the planet. As for the normal space autopilot, it flips and burns in multiple stages that I find tedious and inefficient. It's easier to just do the math and manage it ourselves. That's all for this episode. Farewell, and we'll meet again at Seabright.